The next concept that we're going to discuss is very similar to greatest common factor. It is the least common multiple. This presentation is going to have more detail provided than section 1.2. In order to be able to find the least common multiple, you need to understand basic multiplication. You also need to be able to write a number using prime factorization. Upon completing this presentation, you will be able to understand the difference between a factor and a multiple, understand the difference between a common multiple and the least common multiple, and be able to find the least common multiple, otherwise known as the LCM, for a pair of numbers using lists and/or prime factorization. Starting with some vocabulary terms, we have a common multiple is a number that is divisible by a given set of numbers. This is the exact opposite of what it means to be a common factor. A common factor is a number that divides a given set of numbers, whereas a common multiple is a number that is divisible by a given set of numbers. The least common multiple, or LCM, is the smallest number that is divisible by a given set of numbers. Notice here that we have greatest common factor, least common multiple. Though these concepts are related, they are not the same thing. So the first thing that we want to do is we want to find the least common multiple using lists. We want to start off by listing out at least 5 multiples. For instance, if we want multiples of 2, I want to multiply 1 times 2, 2 times 2, 3 times 2, 4 times 2, and we would continue in this fashion. Note that these lists do go on forever. We're going to do this for both numbers, and then we want to identify numbers that appear in both lists. These are referred to as the common multiples. The smallest number in the list of common multiples is known as the least common multiple. So let's look at some examples using lists. If we start with A, 3, and 4, the first thing that I want to do is I want to list out multiples of 3. So again, I want to take 3 and multiply it by progressive or successive numbers. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Times 6 is 18. 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. 3 times 10 is 30. 3 times 11 is 33. 3 times 12 is 36. And 3 times 13 is 39. Again, this can continue forever and ever. Alright, so that's 3. So let's work with 4. Same thing, I want to multiply 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. 4 times 7 is 28. 4 times 8 is 32. 4 times 9 is 36. And 4 times 10 is 40. Again, this list can continue on forever and ever. So now I want to know what are the common multiples. So what numbers appear in both lists? Well, if we look at this, we have 12 appears in both lists. It is a common multiple. We have 24 appears in both lists, so it is a common multiple. And 36 appears in both lists. One thing to note is that your common multiples, this will go on forever and ever as well. From here, we want to identify what is the least common multiple. And so what is the smallest number on our list? The smallest number on our list is 12. So the least common multiple is 12. That takes care of 3 and 4. All right, so let's look at our next example, which is 2 and 8. So we want to start by listing out multiples of 2. So I'm going to take 2 and multiply it by 1, gives me 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14. 2 times 8 is 16. 2 times 9 is 18. 2 times 10 is 20. 2 times 11 is 22. And 2 times 12 is 24. Again, this list can go on forever and ever. Let's list out multiples of 8. Things that multiply to 8, things that are multiplied by 8. 1 times 8 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. So what are the common multiples? Well, we do have 8 in both lists. We have 16 in both lists. We have 24 in both lists. And if you were to continue the pattern for the 2's, if you continued multiplying by 2, you could add 32 and 40, and again this list will go on forever and ever. So our common multiple, or our least common multiple, the smallest number on this list is 8. And we're done. Okay, for C, you may want to get a calculator out just to make sure that you do multiply correctly. We are dealing with some larger numbers here. So let's go ahead and list out multiples for 28. 28 times 1 is 28. 28 times 2 is 56. 28 times 3 is 84. 28 times 4 is 112. 28 times 5 is 140. 28 times 6 is 168. This list goes on forever and ever. Hopefully this is enough for now. So let's look at 42. 42 times 1 is 42. 42 times 2 is 84. 42 times 3 is 126. And 42 times 4 is 168. Again, this list goes on forever and ever. From here, we want common multiples. So our common multiples, we have 84 appears in both lists. We also have 168 appears in both lists. And again, this list will go on forever and ever as well. Okay, so now what is the least common multiple? Well, the least common multiple, the smallest number in our list, is 84. And there's your least common multiple. Now, this pair of numbers wasn't too bad, only because we managed to find a least common multiple fairly easy. But note that we do have to keep extending these lists out if we can't find a least common multiple. There's no limit to how far out we might have to go in order to find the least common multiple. So let's look at the last example. The last example, we have 48 and 60. So let's work with 48 first. 48 times 1 is 48. 48 times 2 is 96. 48 times 3 is 144. 48 times 4 is 196, and 48 times 5 is 240. If we look at 60, 60 times 1 is 60, 60 times 2 is 120, 60 times 3 is 180, 60 times 4 is 240, and this list keeps going. I stopped there because right now I see a common factor. We have a common factor of 240. Or common multiple, I apologize. Common multiple. 240 is a common multiple. If you were to continue your lists, you would also get 480, 720, 960. So our least common multiple is going to be 240. So that takes care of finding least common multiple using lists. And as you can see on the last two examples, this can be rather involved if your numbers are larger. Your common multiple is going to be even bigger. And so you do want to be careful when creating these lists. You do want to make sure that you are careful in your multiplications, because for instance, if I had multiplied 48 by a number incorrectly, then that's going to throw off the whole thing and make it a lot harder to find your common multiple. Now, one thing to note is once you have your least common multiple, anything times that number will be a common multiple for the original numbers. Notice that in the example A, for instance, we had a least common multiple of 12. Well, if you multiply 12 times 2, you get 24, which is on our list. If you multiply 12 times 3, you get 36, which is on our list. Similarly for the other examples. The next thing that we want to look at is finding the least common multiple using prime factorization. To start with, write each number as a product of prime factors. We're going to start by putting all factors that appear in both lists in the least common multiple. This is the greatest common factor. The greatest common factor will be in the least common multiple. From there, we want to put all remaining factors in the LCM, and finally multiply the results to get the final answer. Now, all of the examples we're going to look at here, we've done before, so I'm going to go ahead and just write out the prime factorization to figure out. If you don't remember how we got it, go back and look at the previous section. But to start off with, let's go ahead and factor each one of these. So let's look at example A to start off with. Example A, we have 3 and 4. Since 3 is a prime number, I'm just going to say that it's equal to 3. 4, if I write it in expanded form using prime factors, this is equal to 2 times 2. So now, to find our LCM, the first thing that I want to do is put any numbers that appear in both factors in the LCM. For this example, there are no common factors to put in the LCM to start with. So then we're going to go to our second step, which is put everything else in the LCM. So I want to put a 3 and 2 2's. From there, we want to multiply the results. 3 times 2 is 6, times 2 is 12. So our LCM is 12. Looking at example B, we want to go ahead and again start by doing the prime factorization. So 2, since it is a prime number, it's just equal to 2. 8 is equal to 2 times 4, and 4 is equal to 2 times 2. So to start with, for our LCM, I want to put any common factors that they have. Here, they have a 2 in common, so I'm going to start with a 2 in my LCM. And from there, I want to put everything else in there as well. So we should have 2 more 2's in the LCM. If we multiply this out, we get 2 times 2 is 4, times 2 is 8. That is our final answer. Let's move on to example C. Starting with the prime factorization for each number, we have 28 is equal to 2 times 2 times 7. 42 is equal to 2 times 3 times 7. So let's begin with what they have in common. In common, we have a 2 and a 7. So I'm going to start by putting that in my least common multiple. From there, I want to put anything that I haven't considered yet. So for instance, the 2 from 28 still needs to be in the LCM, and the 3 from 42 also needs to be in the LCM. From there, we can go ahead and multiply our results together. 2 times 7 is 14, times 2 is 28, times 3 is equal to 84. For our last example, 48, if we factor it, we end up with 48 equals 2 times 2 times 2 times 2 times 3. 60 is equal to 2 times 2 times 3 times 5. So for our LCM, let's start with what do they have in common. Well, in common we have 2 2's. We also have a 3. So start by putting that in the LCM. From there, I want to put everything else that I haven't considered yet. So I still have 2 more 2's and a 5. From there, if we go ahead and multiply this out, 2 times 2 is 4, times 3 is 12, times 2 is 24, times 2 is 48, times 5 is 240. This is one method that you can use for prime factorization in order to find the least common multiple. The second method that you can use is, instead of looking at what do they have in common and what do they not have in common, what you can do is start with one of the numbers. For instance, if we look at 3 and 4, what we're going to do is, in our LCM, start with the factorization for one of the numbers, for instance 3. From there, I want to look at my other number and determine if each factor is already represented in the least common multiple. So for instance here, is 2 in the least common multiple yet? No. So we're going to add it. Is there a second 2 in the least common multiple? No. We want to add that one as well. Now if we go ahead and multiply, we get 3 times 2 is 6, times 2 is 12. Let's look at another example. Let's look at 2 and 8. 2 we said was equal to 2. 8 we said was 2 times 2 times 2. So again, for my LCM, I'm going to start with just one of the numbers. Let's say the 2. For the second number, I want to see if it's already represented. Is the 2, the first 2, do we have a 2 in the LCM? Yes, so we don't need that one. Do we have a second 2 in the LCM? No, so we need to add that one. Do we have a third 2 in the LCM? No, we need to add that one as well. So we get 2 times 2 times 2 is equal to 8. Let's look at 28 and 42. If we go ahead and start by looking at our prime factorization, we said 28 was equal to 2 times 2 times 7, and we said 42 was equal to 2 times 3 times 7. So for our LCM, I'm going to start by putting all of the factors of the first number in the LCM. So we have a 2, and a 7. For the second number, do we have a 2 in the LCM? Yes, so we don't need it. Do we have a 3 in the LCM? Not yet. Let's go ahead and put that in there. And finally, do we have a 7 in the LCM? Yes, so we do not need to repeat the 7. We get 2 times 2 times 7 times 3. If you multiply this out, you will get 84. For our final example, just one more example to see how this works, we have 48 is equal to 2 times 2 times 2 times 2 times 3. We have 60 is equal to 2 times 2 times 3 times 5. So I'm going to start by putting all of my factors for the first number in the LCM. We have 4 2's and a 3. Let's look at 60 now. Do I have 1 2 in the LCM? Yes. Do I have a second 2 in the LCM? Yes. Do I have a 3 in the LCM? Yes. Do I have a 5? No. This is the one factor that we need to add into the LCM. If we multiply this out now, we get 240. Either way you look at the problem, you should still get the same result for the LCM. We will be looking at least common multiple several times throughout this section. The first place that we will see this is when we talk about adding and subtracting fractions later in this section. We will see it again when we talk about solving systems of linear equations using the elimination method in Chapter 4. And we will extend the concept when we look at adding and subtracting rational expressions in Chapter 7. If we have time, we may even see it when we talk about combining roots in Chapter 8. Let's go ahead and bring the two concepts of greatest common factor and least common multiple together so that we can look at what the similarities are between them as well as the differences. The first thing to note, the greatest common factor is never larger than either number. Since there is a finite number of factors, you can always find a largest. On the flip side of the coin, the least common multiple is never smaller than either number. Since there is an infinite number of common multiples, you cannot find a largest. You can only find a smallest. For our second set, we want to look at special cases. There are three cases when we talk about greatest common factor and least common multiple. The first one is if the two numbers are relatively prime. So what does it mean to be relatively prime? Relatively prime means that they have no common factors other than 1. So for instance, the first example that we looked at on each one of these, 3 and 4, are relatively prime. They have no common factors other than 1. So what it means is if they are relatively prime, the first thing that we have is the GCF is always 1. And that was what we came up with. They have no common factors other than 1. The least common multiple, since they have no common factors, is going to be the product of the two numbers. There's no overlay. And so our LCM, we have to include all the factors of both numbers, or both numbers. So if we multiply 3 times 4, we get 12. And that was what we came up with for our least common multiple. The second rule, or the second condition that we have, is if one of the numbers divide into the other. In this case, what we have is the GCF, the greatest common factor, is always the smaller of the two. Our second example that we looked at was 2 and 8. So what is a number that divides 2 and 8? Well, then it has to be 2. 2 divides 2, and by the definition of this case here, 2 divides 8. The least common multiple, if one of the numbers divides the other, is always the larger of the two. Is 8 divisible by 2? Yes. Is 8 divisible by 8? Yes. So these two cases here together constitute the two easiest examples. You don't have to do any work. Either your GCF or your least common multiple is already there in the example of the second case, or your least common multiple is the product of the two numbers, and the greatest common factor is 1. If the numbers have some common factors, just some but not all, if they have some common factors, you will need to do some work to find the greatest common factor and the least common multiple. In the future, finding the GCF is not always required, but will allow you to solve problems in fewer steps. If you struggle to find the greatest common factor, start by just finding a common factor. Similarly, finding the least common multiple will not be necessary, but will allow you to work with the smallest numbers possible and allow you to solve the problems in fewer steps. If you struggle to find the LCM for a set of numbers, note that multiplying the two numbers will always result in a common multiple.